Okay, Dr. G is about to give you some info on calcium homeostasis. You and I know that homeostasis is the body's method of maintaining normalcy for many of the processes or all of the processes that goes on. For example, keeping the correct amount of sugar in our blood, keeping the correct amount of water in our blood, keeping our body temperature as constant as it should be, etc., etc. Well, homeostasis as it relates to calcium is maintaining the correct concentration of calcium in the blood. Remember this, get this straight. Yes, our bone stores most of the calcium in our body, okay? But where the calcium is critical in terms of a situation that can end up being fatal is in the blood. We need to keep a relatively narrow range of calcium concentration in the blood constant. How narrow is that range? I'm going to show it to you here. See, it says maintain 9 to 11 milligrams of calcium per 100 milliliters of blood. That's not very wide, 9 to 11 milligrams. Well, how serious is this? It's serious. Check this out. If the calcium concentration is too high, you get cardiac arrest. If it is too low, you get respiratory arrest. Well, calcium is important for many things, including the nervous system uses it to help, conduct impulses. Your blood needs it in order to clot when you get a hemorrhaging. But check this out. The muscles of your body, all the muscles require, it's an absolute necessity to have calcium. They cannot contract without calcium. How does this relate to what we just said? The fatality that can happen if it's too high or if it's too low. Let's check about if it's too high first of all. Isn't your heart a big muscle? Yes, it's cardiac muscle. What if there's too much calcium? Well, that can cause the heart to race and go into fibrillation, and that can drive you into cardiac arrest. What if calcium is too low? Remember your intercostal muscles? You remember that diaphragm that controls your respiratory inspiration and exhalation? What if there's not enough calcium to maintain proper rhythmic contraction and relaxation of the diaphragm muscles? Just that one. You can see how you can suffocate. Your lungs stop operating. You can't breathe. Hey, I cannot overemphasize how important and how significant it is to maintain that calcium electrolyte balance in the blood. Remember, in the blood. Let's go on. So what does the body do? First of all, what does the body do if the calcium level goes too low? Okay, notice it says a stimulus and receptor. When the calcium ion level drops in blood, it is detected by parathyroid cells. What's the control center of any homeostasis? Our brain. So once this drop is detected, this gland that I'm showing you here, this butterfly looking gland that I'm showing you here, gets the impulses, gets the stimulation to up-regulate, or I would say increase its secretion of the hormone that these four little glands within the thyroid glands called parathyroid glands, they increase the amount of parathyroid hormone that they would normally secrete. Let's go to this one and show it bigger. Here is the relative location just around our neck region here. See, folding right around our trachea, just below our larynx. That is the butterfly shaped looking thyroid gland, but this time we're not focusing exactly on the thyroid gland. We are focusing on these four, 1, 2, 3, 4, 1, 2, 3, 4 little glands together called the parathyroid glands, hence the hormone parathyroid hormone, or PTH. This is a chemical messenger. What does it do? Well, it targets some effectors. You know what effectors are, right? It targets some effectors. It targets these things to get that calcium back up to normal levels. Let's see if we could get some writing going here. Let me see if we could grab a pen. See pen. Okay, it seems like I have a pen right here. Probably change the color here. And let's see. Cells are involved, and they're actually bone cells are involved. And if it's too high, the bone cell that is involved is osteoclast. Target organs are involved, namely kidney and also intestines. Okay, let's see how these targets, these effectors, these are the responsive structures to the message brought by the parathyroid hormone. Let's get out of this pen and move forward a little bit to get some more diagrams. So here we go. The parathyroid hormone, let's get a pointer. The parathyroid hormone goes to the osteoclast. Now remember, endocrine hormones travel in the blood, so it's going to get to its target anyway. So osteoclasts are the cells. Why are osteoclasts target? Well, let's remember what osteoclasts do. Osteoclasts go to bone matrix, they break down all bone matrix, and whatever mineral source was in the matrix is liberated back into the body fluid, which will eventually get to the blood. So you can see how it makes sense to now increase. These are not going to be operating under normal rate. You're going to up-regulate the rate at which these guys take the calcium ions out and shuttle it into the blood because the blood needs it. It's more critical in the blood. So that's one mechanism. The second mechanism, and it doesn't know order in which it happens. These are all things happening at the same time. The next target is the kidneys. Now what does the kidney do? The kidney normally excrete or get rid of excess calcium. At a point in time when the blood level is down, we don't want the kidney to be thrown away. That thing becomes precious. So parathyroid hormone, PTH, stimulates the kidney to hang on or keep or resorb that calcium, which would ordinarily go into the bathroom. So the kidney grabs onto it and makes it available for the blood. Alright? Third mechanism, you remember the kidney is one of those organs that turns that calciferol molecule into the active vitamin D, calcitriol. What does vitamin D do? Vitamin D is absolutely necessary for the absorption of calcium from our intestines. So the amount of vitamin D through the small intestines is upgraded, its level increases, and that increases greatly the efficiency of the uptake of calcium from our food in the gut and make it available for the blood. So from this three-pronged approach, you see, the homeostatic mechanism is going to bring that calcium back up into normal level in the blood. Now that's fantastic. You got to remember, therefore, the chemical messenger is PTH. That's if it's too low. The target is osteoclast, resorption of calcium back into the blood. Kidneys, withholding and making calcium available back to the blood. Small intestine, increase absorption of whatever calcium that is there by the stimulation of vitamin D due to the production of more vitamin D from the kidneys. Alright, so there you have it. If it's too low. Okay, what happens if it's too high? That's bad also. If it's too high, remember, cardiac arrest. we want to bring it down. A different hormone by the name of, let's get a pen again, different hormone by the name of calcitonin. See, calci sounds like calcium. Tone it down, tone the calcium down. Calcitonin. That's if calcium is too high and needs to come down. If it needs to come down. Okay? I'm going to put calcium needs to come down. Where does calcitonin come from? Calcitonin come from a set of cells within the thyroid gland. Again, this time these cells are called parafollicular, from follicle. I think it's 2 L's. Follicular cells. They produce the hormone calcitonin. Calcitonin does the exact opposite. The opposite of parathyroid hormone. Calcitonin does the opposite of parathyroid hormone. Calcitonin stimulates osteoblasts. Well, how would stimulation of osteoblasts do that? What do osteoblasts do? Osteoblasts take calcium, mineral salts from the blood, and deposit it in the bone. This time we don't want the calcium to increase, we want it to decrease. So upregulating the rate at which osteoblasts operate is going to pull that calcium from the blood, store it in bones. That's going to help to bring it down. Remember, at the same time, a hormone that will stimulate one type of bone cells will inhibit the next. So calcitonin stimulates osteoblast, B for building, stimulates osteoblasts to increase their rate of depositing calcium into the bone. Okay? At the same time, it will inhibit osteoclasts from tearing up bones and taking calcium out of it to put in the blood, because we don't want to put more calcium in the blood where there's already too much. Okay? Same way, when parathyroid hormone stimulated osteoclasts to take it from the blood and take it from the bone and put it into the blood where it's needed because it was too low, then you'd want to also inhibit osteoblasts from doing the opposite. You see? So that's how that goes. Alright. Well, let's look at a negative feedback loop that we're accustomed to. Here is the normal range set point. Calcium went down below where it's supposed to be, and so what happened? Parathyroid glands activated. They secrete parathyroid hormone, PTH. Alright, that results in small intestines increasing its absorption of calcium due to the vitamin D increase that is stimulated by the kidneys. And the kidneys itself, see, the kidneys itself gets the message to hold on to calcium and not excrete it at that time. And the PTH also does what? Stimulate osteoclasts to take it from the bone and put it into the blood. Moving on to, we see here the role that vitamin D plays in reabsorption of calcium, or absorption of calcium in the gut. However, the role of calcitonin here that we here is to actually do the opposite effect of what PTH will do. Okay? Here is a cartoon of osteoblasts You see, increasing deposition of calcium in the bone. So it's taking it from the blood, putting it into the bone. And here is the normal work of osteoclast, which would increase if there's not enough. And you see what they're doing? They are absorbing the calcium back into their bodies, and then they're going to release it. They're going to release it into blood. That's the opposite. They're going to release it into blood to increase it here. So if you look at the green boxes, they explain what's happening as far as calcitonins work, and if you look at the orange box, it's explaining what's happening in terms of PTH as it relates to the two different cells here. Let me see how much time. Let me take a little minute to do something that I normally do here. Okay, so this is a little cartoon I normally do just to explain and to show the relationship between two different hormones and two different bone cells as they interrelate in this calcium homeostasis thing. So what I normally do, by the way, before I go further, throughout this whole lecture I've been referring to calcium. I've been just saying calcium, but you know, you need to remember that we take in these mineral salts. We call them mineral salts in the form of salts, and then when they are dissolved in water, they dissociate and they are in iron. So if you notice, every time I wrote Ca, I always put plus because calcium has two positive charge in it. So it's calcium in the form of calcium ions. That's what we're talking about. All right. So just make sure that you make that little understand, get that a little bit straight. Okay. So let's go ahead, and I'm going to sketch what I will call like a bone here. This is a bone here, and then over here we're gonna put like a pool of blood. That's something here. I'm gonna just put some what would appear like red blood cells. It's not nothing artistic. I just want to put some, just to get the idea. We could probably drop one or two white blood cells in between just to make it look authentic. And I am going to put some calcium ions over here. And this could be written either as plus, or you can also write it as Ca plus 2 as well, indicating that these are actually calcium ions. Put some over here too. So calcium ions in the blood. All right, in the blood. What I'm going to do, I am going to say stretch this over here as a shuttling device. So let's talk about what osteoclast does. So if calcium in the blood is too low, it goes down. Calcium goes down, it's too low. Then here's let's put osteoclast here. Put osteoclast here. Osteoclast activity is going to be increased. All right. And what osteoclast is going to do is to resorb calcium. So it's going to resorb calcium from bones. It's going to take it from the bone and shuttle it over into the blood because the calcium in the blood is too low. That's bad. What is going to stimulate osteoclast? Remember, it is going to be the hormone PTH. That's what's going to stimulate osteoclast, the hormone PTH. So osteoclast activity goes up, calcium is removed, shuttled over into the blood to help to raise that calcium back up. Well, let's see what happens in the other situation. The next hormone we're going to deal with is not PTH at all, although it comes from some cells within the thyroid gland called parafollicular cells, as I already mentioned earlier on. So what I'm going to do, I'm going to put the arrow in the opposite direction here now, showing that if calcium rises for whatever reason, rises too high, it's too high in the blood, I use an upward arrow to represent too high, a downward arrow to represent too low, then calcium will be shuttled and deposit into bone matrix. But which bone cells do that? This time it is osteoblasts. Remember, blast, B for building bones. And osteoblasts will be stimulated by a different hormone, that's calcitonin. Remember, calcitonin is secreted by parafollicular cells found within the thyroid gland. So that's calcitonin hormone is going to stimulate the osteoblast to shuttle calcium ions from the blood and deposit it into bone. So you can see how these two different cells operating differently, and these two different hormones operating differently, to use these cells to do shuttling backward and forward, as the case may be, trying to balance out that proper level of calcium concentration, calcium ions concentration in the blood. Notice this cartoon is just explaining as far as the cellular activity is concerned. But remember, if it's too low, you have the activities of the kidney and the intestine as well. So this cartoon is specifically to show you the balance between osteoblasts and osteoclasts, and between calcitonin and PTH. So I hope that this was able to be quite helpful for you. Look at this as often as you want, and there we go. The role of calcium homeostasis as far as bone remodeling is concerned, and the role that is played by all the players in keeping calcium concentration within normal limits. Bye.